Welcome back. As you know, I am Eli, the computer guy, and I'm a very, very happy boy today. So, a lot of people just think I'm an over the hill, broken tech professional that is simply snarky about everything. And I say au contraire. I'm snarky about stupid crap. You give me something really cool to be excited about, and I'm gonna be a very, very happy geek. So this is a great new little toy that I got from a company called Blues. Hashtag not a sponsor. Hashtag donor box link down below if anybody wants to throw any money at me. But anyways, I went to CES 2024 a couple of weeks ago, and when I was there was a company that basically creates IoT modems, and this is their developer kit. And the really cool thing about Blues is that you buy the IoT modem, and it actually comes with its own built-in SIM card that you're not supposed to have to do any configuration for. So if you want to create something called an IoT device and be able to have it communicate with the internet or some kind of communication network, one of the issues is that you have to get a SIM card, so you have to buy the SIM card, you have to do some kind of administrative process for the SIM card, you have to put that into your system, and then think about doing that if you have 100 devices or 1,000 devices or 100,000 devices. All of a sudden, your day is a hell of a lot of paperwork. So what the cool thing is with Blues, is that they have this IoT modem. The SIM card component is already installed. When you buy this, they auto-register and do everything that you need to have it work, so that the idea the idea, at least, is that you can pull it out of the box, you can slap it into your device, you can turn your device on, and it can talk to the world, right? So I'm very excited. So like I said, I literally just got this in the mail. The cool thing was when you buy this particular modem, it comes with 500 megs of communication over a 10-year lifespan. Now that might not seem like a lot, right? Like if you're used to the YouTube world, or if you're used to Spotify or downloading large like multimedia files, hearing that you only get 500 megs of data probably sounds like crap. But remember, in the real world of technology, a lot of times you're just sending text values, right? If you have a temperature sensor, if you have a GPS sensor, if you have any of those types of sensors, you're just sending text back to your main server. And so 500 megs of just text is actually just a hell of a lot of data. You can also apparently buy more data if you need it. But yeah, so basically you can have your little IoT device, again, doing environmental sensors, those types of things. The other interesting thing that you could do is you could have what's called pushing intelligence to the edge. So you could actually have a very powerful computer sitting somewhere that's doing machine vision, that's doing machine speech, something like that. It's doing all of this processing, and then when it sees an event, when it detects an event that you might be interested in, it can then basically send a little SMS message, essentially a little text message to you to say, hey, an event happened. So that way, all of the processing is going on that local device that requires a lot of resources, but then when, again, an event happens, it can just send a little message to you to state that an event has happened, so you can decide whatever else that you're going to do. So anyways, basically, since I got this nice little Blues cellular modem, basically this IoT modem, what I want to talk about today is the concept of what is IoT, what is the Internet of Things, and why is it so important in the modern world of technology. So then the first question is what is IoT and why is it so important? So IoT is called the Internet of Things. There used to be a secondary abbreviation called the Internet of Everything, but that all simply got mashed down into one thing. There used to be something called the Internet of Things, and there was also something called the Internet of Everything, and then, normal people got involved, and so it all got mashed together. There actually used to be two distinct definitions. Basically, the idea used to be that the Internet of Things were devices that were able to connect to the Internet, but might have some kind of middleware device to allow them to connect to the Internet. So imagine sensors in your house. So if you have like a security system in your house, so window brake sensors, motion sensors, those types of things, things, they would communicate back to a base station, and then that base station would then relay the information out to the internet. That was much more of an Internet of Things world, where the idea of Internet of Everything was that everything was actually directly connected to the internet. So basically, in the modern world, this 5G world that we were supposed to be in 4 years ago, Eh, right. The idea is, imagine if every single sensor in your house actually was connected directly to the internet so that it didn't need to go through any kind of middleware type system within your premises in order to get that information out to the internet or do any kind of communication. So IoT had a middleware system. IoE basically did not, at least a local premises middleware system. But again, people couldn't keep up with that. 5G, you know, again, things to actually be snarky about. 5G is something to be snarky about. 5G hasn't exactly worked out how we were told it was going to work out. And so everything is now considered IoT. And basically, the idea with IoT is that we have, a tremendous number of these gadgets, these technology devices, that by hook or by crook, by some way, they are able to communicate with the internet. And generally speaking, they're able to get communication from the internet. So in the IoT world, think about this in the modern world of your TV. Your smart TV is an IoT device. If you have an Apple Watch that has an LTE connection, that is an IoT device. Again, this blues, this little modem here, is an IoT device. And so the idea is that then all of these devices are able to communicate up to the internet to pull down whatever information that they care about. It might be things like text messages, it might be email, it might be Netflix shows, that type of thing. Or when you start getting the industrial world, once you start getting to the enterprise world, you start getting things like sensor values. So like one of the problems that we had in the past, before we get into the whole IoT world, is that if you had sensors in a premises, those sensors most likely communicated back to some kind of hub system. And then that hub system was just that hub system, right? So if you had security sensors or whatever within your premises, and there was a window got broken or something like that, that would send a signal back to your main little hub system, and then that might simply send a single phone call out to your security company or something like that for them to do something with, right? So back then you had all of these sensors, but everything was very contained within your premises. So one thing, it wasn't necessarily resilient because everything was contained within your premises. If that one hub server failed, all of your sensors were down. Think about this. If you had 1,000 sensors within your environment and they all connected back to one system, and that one system got unplugged, which I've seen happen, your 1,000 sensors are basically worthless. 1,000 sensors, 1,000 cameras, 1,000 whatever else. All of a sudden, they're completely worthless. Beyond that, too, is with all this information going back generally to these proprietary systems, that there was no way to really mine information to figure out what was going on. A motion sensor might go off, and depending on the alarm settings, that might set the alarm off or it might not set the alarm off. But you couldn't do a lot with that. One of the interesting things to be thinking about as a business owner, as a decision maker, is that the more information you have, the easier it is to run your business. So if you start seeing motion sensors going off at 5 o'clock in the morning, more than they normally do, this may tell you that your employees are getting to the office earlier than they normally do. And this might be something that you need to look into, for whatever reasons, maybe shifting the schedule, maybe doing something like that, right? Having that type of information could be useful. If you can have that information from multiple different environments, imagine if you have facilities throughout numerous different states or numerous different cities, being able to pull in all of that information into one type of database server and then mine information out of that database server can be very useful for you as a decision maker. And so that's where we get into the IoT world, this idea of the Internet of Things. Is now all of your devices can communicate to the internet, so generally to your server systems. All of that information can be logged and stored there to trigger whatever types of events that you want to have happen, and it's all in that one data store type environment. So if you want to run AI algorithms against it, or and basically any type of just standard statistical algorithms against it, you can try to pull out information that you may not have seen before. And so that's what we're talking about with IoT. IoT is the idea that all of these different devices actually have a connection to the internet. They can communicate with the internet, they can get communication from the internet, and generally you're able to design it to do whatever you want it to do. Now, one of the things that you need to be thinking about if you want to start bringing IoT into your environment is what is the architecture for your IoT infrastructure going to look like, right? So, in the modern world in the 2020s, one of the issues with a lot of modern technology professionals is that they've been really used to TCP/IP version 4 for way too long, right? So again, I started in technology in 96. I got my MCSE back in 2000. And back then in 2000, there were still a number of different technologies and also protocols that we actually had to learn. Things like token ring, was it ThinNet, ThickNet, FIDI? There's a whole bunch of crap that I actually haven't had to take a look at in a long time. And basically, Ethernet standard, the standard that we generally use today, was just simply one of the standards that we had to learn about. And the thing was, all of these different technologies, they had their benefits and they had their drawbacks. At the end of the day, Ethernet and the protocol TCP/IP4 was just better all around. And so everybody started using that. The issue that you run into, though, again, now that we're in the 2020s, is that technology has moved along, and just like back near 2000, all this networking technology coalesced around Ethernet and TCP/IP version 4. As time has gone by, 20 years down the pike, new technologies and new protocols have come out that are actually very interesting and very useful. But sometimes some people get so focused into what they've always been doing, they don't think about these new technologies and how this can be good for their systems and for their infrastructure. And so when you start thinking about IoT, one of the things you need to think about fundamentally is what type of technology and what types of protocols will be most appropriate for the systems that you're trying to create, right? So again, so in the modern world, like what we've had for a long time now, you have your cloud, you have your facility. In your facility, you have a crap ton of computers. They all connect to a router, a modem, and that gets you out to the internet, right? So this is basically how things were like 2002, 2003. You then add a wireless access point to that so people can connect wirelessly, and that's the architecture that we had before. And so when you're thinking about IoT in this kind of world, right, everything is Ethernet or wireless. Everything is TCP/IP version 4, whether it's your printer, whether it's your smart television, whether it's your watch, it's all connecting to the router, and it's all going out to the internet. Now, the nice thing with TCP/IP4 and Ethernet and Wi-Fi is it's good for many different solutions, right? If you're sending an email, Ethernet and IP4 is great. If you're downloading and watching a Netflix movie, well, let's be honest, it's actually pretty crappy at doing that. But the hardware has gotten good enough you don't realize how crappy it is, right? If you want to do real-time communication, also it's still pretty garbage at that, to be frank. But the hardware and the software is good enough to make it so that the garbage quality isn't so noticeable, right? And so that's the thing, is everybody uses TCP version 4 and Ethernet because at least it seems like it's doing well and you can use it for a lot of different stuff. If you're sending an email, if you're watching a Netflix video, if you're Zoom chatting with your grandma, IP4 and Ethernet, seems to work good for you. But one of the problems that you run into, though, is when you start having these IoT devices, right, you get into weird issues. Like things like what happens when you have Wi-Fi dead zones, right? So let's say you have a building like this, and you have a big, thick wall right here, and you need to put a device on this side, and the Wi-Fi signal can't get through. Well, in the old days, right, if you're going to put a server, Well, maybe you drill a hole through the wall. You do something, right? If you're going to put multiple computers here, maybe you run cable, right? If you're going to put a few $1,000 at least system on the other side of this wall, it makes sense to spend $200 or $2,000 to somehow figure out how to make this no longer a dead zone. Well, here's the thing, right? The whole dev kit from Blues for this little IoT modem here, cost $100. $100. You get this whole thing. It comes with a feather board for Arduino, comes with the carrier, and comes with the modem itself, plus the 500 megs. This is $100. And the important thing to be thinking about is that if this is $100, an actual thing that you would be deploying into the field would be a lot less, right? So like one of these IoT devices, if it's a sensor system, might be $50. Again, especially if you're deploying 1,000 of these things, at scale cost for manufacturing, it might be might be $50 a piece. Here's the deal. And again, this is what you got to think about with business, right? If you have a CEO up here, and you tell the CEO you have a $5,000 computer on the other side of this wall that you need to connect to the system, can you get a $2,000 budget to connect this $5,000 server back to your infrastructure? The CEO is probably going to say yes. Oh, well, it's a $5,000 server, so it only makes sense. It only makes sense that we spend $2,000 to connect it to the network, right? Common sense. Here's the thing. What happens when you put a $50 IoT device on the other side of that brick wall? The funny part is, here's a reality lesson for you. You want a reality lesson? This $50 IoT device may be so much more valuable to the company than this $5,000 server. But here's the thing, it's $50. You don't spend $2,000 to connect a $50 device to the network. Every CEO understands that. And now you know what happened to my passion. Anyways, so one of the problems you get to is crap, right? It's in a dead zone. Maybe it's in a facility, like it's a large facility, so these things are all around. And again, they're just not going to do it. They're just not going to spend $1,000 to connect a $50 device to the network. And so I was like, well, then what are you going to do here, right? So if you try to get a T1 connection to all these things, I've actually seen that in Baltimore City. You want to know where your tax money goes in Baltimore City? Every single surveillance camera that the city had for the cops had a T1, a $500 a month T1 line going to every single camera, which again, most CEOs would not agree to. Only politicians spending tax money would agree to something like that. So anyways, you have all these things, so you got to think about it. It's like, okay, well, it's not going to be able to connect wirelessly. It's too far away to connect wirelessly. We're not going to be able to connect it with a hardwire connection. That's not going to work well. So how can we connect this, right? And so that's where you get into the LTE world. So I think 2G is now dead. Is 3G dead? Anyways, you get into 4G, LTE, you get into 5G. And basically the idea is what happens is instead of the device connecting through your modem up to the server, your device can simply connect directly up to the internet, and the data that it's pushing out can be routed however you want, right? So an interesting thing to be thinking about from an architecture standpoint is previously, right, when you're thinking about the old school world of IPv4 and the Ethernet standard, right, you may have had this facility, you may have had your switch and router here, you may have your server, and you may have had your IoT devices. They go into the switch and router, and then that information directly goes in the server, and then the server processes it however it processes it. If there's an issue, it turns on an alarm or something like that. Something to be thinking about, though, is when we start thinking about things like 3G or 4G and 5G and all that, is okay, so we can have our facility here. We have our little devices all over the place. They now have these cellular modems, right? They have the cellular modem, so they can now send up to the internet. From the internet, that either can get redirected down to your server, so it can either be pushed push is when something is pushed to your device, or can be pulled. So it can either get pushed to your server, or the server can go up to whatever your storage bucket is up online and pull it down. And so that way these devices are now able to communicate with the main server that you might have on premises or wherever it is, but now they're going through the internet first. The thing to be thinking about this, again, from the architecture standpoint, is normally if you have a device on the network, your server can send a communication directly to that device. In this process, again, you start thinking about that push-pull dynamic. Your devices send information up to the cloud. That information either gets pushed or pulled down to your server. Your server then analyzes all of the information that comes in and then sends out a command to what would be considered like a command and control server up on the internet. And then you have some device here that would be listening for those commands to trigger an event. So let's say you had a moisture detection, right? So in your facility, you got a lot of moisture detection sensors throughout your facility, and they're sending up all of a sudden, they're saying, oh no, the basement is wet. Your server then gets that information and goes, okay, I have 5 sensors. They've all been triggered that they're wet. It then sends a command up to tell the water pumps to turn on. You basically have IoT devices that are connected to the water pumps that are listening to that command and control server. When they get the signal to turn on, they turn on. Water level goes down. These IoT devices now say, okay, everything is dry. And then your server here sends a shutdown order to the command and control server. Then your water pumps can go, okay, it is time to shut down, and then they're able to shut down. But one of the things to be thinking about with this is, again, that idea of architecture and that idea of technology. We're now using LTE. We might be using things like 5G. We're now using cloud infrastructure. We're now using push and pull techniques for being able to move that data around. And this is something that you need to be thinking about when you start designing these IoT systems. The next thing that you need to be thinking about with these IoT systems is basically how much data do you really need? Okay, so trigger warning. Anybody that's watching this video in Silicon Valley should probably just leave right now. Just go away. You people are addicted to data. I have no idea how to get people off of the data addiction. This is not going to go well. This is not an intervention for the data addicts out there. I'm talking to the folks that haven't snorted a line of data quite yet. But anyways, one of the big problems that we get to in the modern world is when we start talking about data is we hear a lot of stupidity about data. Data is the new oil. Oh my golly. Yeah, it's just, I don't know, people like words. People like to throw words out there. So anyways, there's this idea that data is so important. Again, like your electric car, your autonomous car is supposed to be sending this is not a joke. They're actually selling this crap. 5 terabytes of data a day is supposed to go from your autonomous vehicle up to a Ford or Tesla or whatever else. Sorry. And they think this is normal. They're like, but of course we'd be sending 5 terabytes of data. Why not? Well, one of the things you have to be thinking about, right? If you're not in some weird world, with where 5G is just limitless, because that's one of the big ideas here. Is like 5G is going to allow all of this tremendous amount of data to be transferred, and basically being able to send this amount of data is going to be inexpensive. I don't know what world these people are living in. If you're sending 5 terabytes of data a day, I can't conceive the world where that's inexpensive. And again, imagine a city. Imagine a city of 1 million vehicles, and 1 million vehicles are sending 5 terabytes of data a day. This is where I make buzzwords or whatever. That doesn't make sense on the face of it. The face of it. Anybody who's worked in technology, how can you conceive that makes sense, right? And so anyways, one of the big problems that we run into in the modern world is this idea that data is cheap and bandwidth is cheap, so that you should just use as much as you possibly can. And then you get these modern systems where if you let them use as much as they possibly can, they'll use 5 terabytes a day, and everything kind of goes to hell. So one of the things you need to be thinking about with these kinds of devices is how much information actually needs to be sent back to the decision maker, right? And when I talk about the decision maker, that might be the CEO, that might be the director of IT or the manager, or that might be somebody like the security guard. How much information actually has to be sent to these people for them to be able to have enough information to make a decision and do their job, right? So imagine we have this facility. Again, imagine we have this facility. And we have cameras. We have cameras all over this facility, and we do not want to spend $500 a month on the T1 line per camera, right? Because that is stupid, right? We're not the government. We're not the government. So we're sitting here and we're thinking about this, right? Okay, we got all these surveillance cameras. So what do we care about? What do we care? We don't want burglars. We don't want trespassers. And if there is a trespasser, we want our nice little security guard to go out and confront them. Hey, you kids, go away, right? That's what we want. That's what we want. And so you're sitting there and you're thinking about it. It's like, okay, well, we can put these really high-def surveillance cameras out there. So we can put like 12 megapixel cameras. And Jesus, they'll be pushed at 100 megabits per second or something ridiculous if you actually allow them to. And you're like, oh, that's got to be crappy, right? You think about all these cameras and any kind of networking, they're just going to be pushing a tremendous amount of data. And you're like, oh, that's going to suck, right? Because the idea, again, the old school architecture for surveillance systems is that all these cameras would be connected back to like the central type system. There'd be a whole wall of of video feeds so that the security officer could see what's going on. And when the security officer sees a person in one of those feeds, that security officer can go walk out and say, hey, you kids, go away. But 100 megabits per second, times 30 cameras, that's going to get expensive. So what can we do? What is this person doing? What is this person doing? This person is looking at these cameras. When this person sees somebody walking where they should not be, they go out and see what's going on and tell the kids to go away. So one of the questions can be asked, right, in this modern world, we have OpenCV, we have computer vision frameworks, we have artificial intelligence. Can we do what's called pushing intelligence to the edge? So what pushing intelligence to the edge means is basically, can we make these cameras even smarter, right? So if bandwidth is going to be a resource restriction, if bandwidth is going to be a bottleneck, because it is, right, that's a problem, then can we make these cameras so smart that instead of sending your security guard a full video feed, they can simply detect that a person is walking where they're not supposed to, at a time they're not supposed to, and basically just send a message to our security officer to say, person detected in a blue coat in quadrant whatever 1 minute ago. Right? Isn't that what the security officer would do anyway? The security officer would go, oh, there's a person in a blue coat in quadrant 4. I need to go look for it. So instead of having this officer actually do that decision-making process, what if you had the cameras do the decision-making process? Right? And that's the idea of pushing intelligence to the edge. And so you can push more and more of this CPU or possibly even GPU intensive tasks out to these devices. And again, it might be expensive. So this camera might cost you $1,500, right? You put a nice 12 megapixel camera on it. You put a real CPU in there. You put a solid state drive. At a certain point, it's going to get expensive. It's going to be $1,500. But again, if you're looking at T1 line, costs you $400 a month. That's going to cost you $4,800 a year. Your ROI on this thing is going to be like 3 or 4 months, right? That type of deal. And so the other thing too is, again, when you start thinking about architecture, is you could have this camera recording all the video. You could put a 4 terabyte, you could put a 4 terabyte or a 10 terabyte solid state drive into this camera. It's constantly recording all of this information onto local storage. The security officer gets called out, and then he may have, or she, may have their own little wireless system that's able to interact directly with that camera to see what the history is, to be able to download information, that type of deal. Some kind of like a Wi-Fi sneaker netish approach to architecture. And that's something for you to be considering. Again, when you start designing these IoT systems, is there an analog? Can you send something that corresponds to a much larger amount of data that will be significant, for whoever it is, whatever decision maker is being told to deal with this information? Do you need full video feeds? Do you need full pictures? Do you need these very large amount of data? Or can you basically send the equivalent of an SMS message and have your systems do what the person used to do? And this is one of the things that you need to be thinking about. And again, thinking outside the box when you design in this IoT world. Now, one of the next things that you need to be thinking about in this IoT world are, what are your middle systems going to be, right? So you're going to have something up on the cloud, basically a web, an internet IP addressable system of some sort. It may be in your premises that you have an actual internet, a full internet connection, or it might be up on Azure or AWS or something like that. But basically, you're going to have some system that's up in the cloud, and that is going to be what your devices are talking through. So if you're sending SMS messages, so let's say you configure one of these things to simply send an SMS message in order to relay information, that might have to go through a service such as Twilio. So Twilio is an SMS API type service, and so this could send an SMS message with some information. Twilio can process that and basically send the information on to whatever server that you may care about, right? That's something. You may have your own servers up here. That's for somehow your IoT device. Again, this might be IP addressable, that your systems, your little IoT devices, are able to communicate with directly. But then there has to be some server that these devices are going to be communicating with, and that are then going to also be able to send communications to. So if you build an infrastructure where this is all owned by you, and you understand how that works, well, good. Your life is going to probably be easy. One of the things you do have to worry about, though, is what happens if somebody else owns that middle component. So with Blues, again, not sponsored. One of the interesting things with their system is that this communicates with their servers, and then their servers push and pull the information to your servers, right? So basically what happens here is you have your little Blue device. Your Blue device sends information essentially up to the cloud. Blue has their server that processes the information that gets sent up, and then that information can go to your server, whether it's up on the cloud or whether it's premises or whatever else, basically how you design your architecture. Now, one of the things you have to be concerned about, though, is like this is where we get into the world of like, what do we own? What do we own? So when you used to buy a DVD, right? So if you bought a DVD player back in 2000, right? It did not matter if Toshiba or Sony or whoever else went out of business, right? You bought your DVD player, you bought your DVDs, and that system would function until the DVD player finally died, right? Whether or not you could replace the DVD player is a question. Whether or not you could repair the DVD player was a question. But you knew when you bought that hardware that you could continue using that hardware basically until it died. One of the issues that we get into this modern world, and something you need to be thinking about with these IoT devices, is that the hardware and the software services are integrally linked. One does not work without the other. So you buy this $100 dev kit, you love blues, you slap 1,000 modems into all of your IoT devices, and you're just happy as a geek in a server room, as all your devices are sending their information up to Blues servers. Blues servers does whatever processing and then sends the information on to wherever else. Well, here's a question for you. What happens if Blues goes out of business? All those devices technically can communicate with the internet, but they're hard coded to connect with this particular infrastructure, and so you are now screwed. What happens if Blues isn't making enough money? Because one of the interesting things, again, I'm working with this whole Blues thing over the next week. And when I talk with the Blues folks, one of the interesting things is that there actually is a fee, tiny fee. I have been told it's a tiny fee. So you pay 500, or you pay the amount to buy this, and you get 500 megs of data up to the internet, up or down from the internet. But then there's a little fee. It's just a little fee to take your data from the Blues servers out to wherever it needs to go. It recoups expenses. Well, one of the things you have to ask in the modern world, again, we talk about Silicon Valley. One of the reasons I lose my mind, one of the reasons I get so snarky about Silicon Valley business models or lack of business models is because how many businesses build their infrastructure off of things that they think that they purchased, and then all of a sudden, the company's like, well, we're not making enough money. The investors, if we're going to IPO, we need to increase our revenue so that we look more important to the investors. So instead of a little bit of money we're going to take from you, yeah, we're going to need to take a lot more money from you. Right? And that's a real vulnerability there. Again, we start talking about scale, like a lot of new people, right? Like 18-year-olds, right? You're used to your smart TV, your surveillance cameras or whatever else. And okay, like maybe it was a penny before and now it's 5 cents. You're like, oh, Eli, what? You can't afford 5 cents? Eli, the computer guy, can't afford 5 cents. It's like, oh, I don't mind 5 cents. I do mind it, but I can deal with 5 cents. It's just, 5 cents times a million. That might get expensive very quickly. Because again, think about this. If you start deploying these devices into the field, you sell one, that's 5 cents. You sell two, that's 10 cents. You sell 1,000, you sell 100,000. All of a sudden, if you're going through their systems and they jack up the rate by any amount, your bill to maintain your systems might go up dramatically. It's amazing. It's amazing how one technology, in order to goose their stats, can destroy another technology company that relies on the technology, right? Oh, in order for us to seem like we're more successful, we're going to jack up the rates on all these people that are basically locked into our systems. And then there's going to be a lot of companies that are locked into that system that are now screwed. And so this is one of the things you need to be thinking about with that IoT world is how much do you trust this company from a business standpoint? Again, a lot of my videos, I talk about politics, I talk about business, I talk about other things. People are like, Eli, just state of technology. We just want to know latency. We don't want to know latency and protocols and that kind of stuff. Well, you got to understand, if you're really going to be a technology professional, an actual technology professional, not just somebody who codes or whatever else, you have to think about this business stuff. From a business standpoint, do you trust this company? Do you trust this company to have a viable business model? All right, that's one of the big things. The other thing to be thinking about when you think about this IoT world and we think about these middle systems is, middle. If you've heard about cybersecurity, and if you've heard about, hacking or whatever, you may have heard of the concept of hacking. You may have heard of a middle something. What is that middle? There's something called a man-in-the-middle attack. So if you have a device, and you have your server, and your device is sending information that needs to get to your server, and there happens to be a person in the middle. Funny thing about definitions. So if somebody nefariously does this, it's called a man-in-the-middle attack. If you pay a vendor to do this, they're just your vendor. But the point to understand is that these devices are sending information through this middle third party. And the reality is you don't really know how secure this is. And this is something that you need to be thinking about, right? So if you have these IoT devices that are sending information, right? So if you have a camera and the camera detects a face, detects a person in quadrant 5, I don't mind that. I'll send that data. Okay, send that data through the man-in-the-middle attack vendor and to your server. Here's the thing. What if you're doing license plate readers? What if you're doing credit card information? What if you're doing any kind of personally identifiable information? And your IoT device, because that's the thing, right? With this IoT device, you can send data, you can send text, right? Credit card, social security number, license plates, the whole 9 yards. You can send that, right? So you're now sending that from your device through their systems to get to your system. Now you say, but Eli, our device has encryption. Our server has encryption. We're good. But to get from point A to point B, it's got to go through that middle person. And you don't know what their security is like. Think about this with Twitter. Twitter got hammered for, there was a Saudi Arabian intelligence agent that was working for Twitter. This is a real world thing. Like one of the funny things in the modern world just blows my mind is everybody talks about we're at war. We're at war, Eli. We're in the first cyber war. You talk with anybody, and they all agree we're in the middle of a cyber war. And I'm like, I'm confused because you all are positive we're in the middle of a cyber war, and none of y'all are acting like it. Do you understand how war works? You understand war works? It's not Call of Duty, right? So one of the things with war is, right, intelligence operations. Now, I've talked about this before, right? If I was the head of NSA, I would literally spin up the world's best free VPN service and the world's worst free VPN service. And then I would log the crap out of every amount of traffic that went through it, right? Because some people will be like, wow, this is a great VPN service, so I'm going to use it for my nefarious things. And they would use it. But then other people would be smart. Hey now, they got to be getting paid some way. If that is the best VPN service out there, they got to be making money some way. So no, I'm gonna use this other free VPN service. It might not be quite as good as the best one, but if the quality's not great, right, that means something. It means we designed it to be that way. It's an intelligence operation. It's a psyop. You're not going to use the best one because you think that's being tapped by the CIA or the NSA. So we're going to create crappier versions so that you think the crappier versions are the real ones or whatever else, right? But you got to be thinking about this. Again, Chinese agents are all over the place. Again, NSA agents. I'm not blaming China. Like, we're doing the same thing. Everybody is throwing intelligence agents places. And so again, imagine if your devices are sending personally identifiable information through this third-party vendor, and you really have no idea the security of this third-party vendor. And again, I'm not beating up on Blues here. I think Blues is probably a good company. I don't know. They might have wanted to sponsor me up until about a couple minutes ago. Now they probably hate me. This isn't beating up on Blues. This could be anyway. This could be Twilio. Anybody. You do not know who is working for that company. You have no idea the integrity of their systems. And so this is something for you to be considering when you're going to be sending information, and also how you send information. Do you put your own encryption, right? So, if you have some kind of license plate, 9VZ from Florida or whatever, on your little device, on your little IoT device, do you encrypt this information before it goes through their systems? So even when they do collect it, they can't do anything with it. This is something to be considering. The other thing to be considering with these third-party vendors, especially if they can see your data, is understanding whether or not they might be selling your data, the third parties. Again, not necessarily your data. It goes in the whole metadata thing, right? We're not selling your data. We're selling the fact that 1,000 requests occurred in this particular geographic area on this day. Again, that's one of those things that you kind of need to be considering too. Like if they know, right? If they know, oh, there's some kind of, event tracking. Let's say you're tracking people or whatever. If the information that you're sending is something that can be identified as some kind of people tracking information, right? They may just have their own database that says some kind of people tracking event, occurred at this, because this has GPS. This has GPS built into it at this GPS location at this time. Again, since Silicon Valley thinks data is oil for some reason, they collect all this information, and somebody might be interested in getting their hands on what seems like worthless data. Right? Okay, a person event at this GPS at that time, why is that valuable? It might be valuable to developers, right? So if somebody's thinking about developing a new area, putting in hotels or whatever, grocery stores or whatever else, being able to try to get this information might be very useful for them. Right, there's any number of things where this kind of information that's not even necessarily the data that you're sending might be useful to some kind of some kind of other person, and this is something that you need to be considering when you're using these third-party vendors. And again, as I always say, distrust, verify, stay suspicious. Trust no one ever. Trust no one ever. Trust the audit for 2 seconds after the audit occurred. When an audit happens on systems, you know at the time the audit occurred what the status of the systems were. You do not know what the status of the systems were 5 minutes before the audit, and you sure as hell do not know what the status of the systems are 5 minutes after the audit. So distrust, verify, and just keep being a snarky bastard. So anyways, there you go. There are some thoughts on the wonderful world of IoT. And look at my face. I'm happy about this. This is really cool. Again, on the main YouTube channel, what I've pivoted towards this year is basically building real projects. So the big problem that I've seen over the past couple of years is that we have more and more technology coming out, and we have more and more people thinking they understand what the technology is, and then we have a whole bunch of people that are talking about technology that are never going to deploy it. Again, we keep hearing about things like AI, and large language models. Large language models are going to destroy the world. How? Seriously, how? What does that deployment look like? Anyways, right? And so what I'm trying to do on the main channel is actually build projects. So this year, I've already built a couple of projects basically using OpenAI's API to create intelligence for systems. So I have a little Louis Rossmann hunting robot, and I'm teaching that Louis Rossmann hunting robot how it needs to do things. And so there's some communication projects that I've done. So I've created these projects and basically showing you how you can do things like talk to a computer. How can you talk to a computer? How can you have the computer talk back? The next class, the next whatever class show that we did is how can we talk to the computer and use OpenAI to come up with responses to send you answers back, so you can make it a much more organic interface with your robot or computer. Class I'm about to do probably tomorrow is actually on caching systems. So when you do the communication with OpenAI, you get the response back, actually caching that response so that if somebody asks the exact same thing later, instead of going out to OpenAI, you can go to your local data store to be able to pull what the response is supposed to be, right? That's the kind of stuff that I'm doing on the main channel with the idea of whether it's AI, whether it's robotics, whether it's quantum computing, so many of these technologies, getting away from the theory, getting away from the talk, and actually building some stuff to show you, what the technology actually does, and to think about how you would use it in a real deployment. Again, what does the architecture looks like? When you talk about AI, right? People nowadays, AI. I hear very few people talking about the architecture required to support AI systems. Funny that, because you actually need to know something about technology to talk about architecture for supporting AI systems. So anyways, what I'm excited about with this is, again, this little guy has a GPS built into it. It has the cell connection, the LTE connection built into it. Has a couple of other things. And so on the main channel, we're going to be building some IoT projects to show you how this kind of things works. So we can do a little vehicle tracking. So like with this, just with this right off the bat, we should be able to create a vehicle tracking system with a little bit of code. So that's one of the things that we're going to do. And we're going to do a whole bunch of other things, again, with this idea of showing you how to push intelligence to the edge and then be able to send communication through something like with this IoT device and that type of deal. And so that's why I'm excited about this IoT thing, because we are gonna be playing with this quite a bit. And so anyways, yeah, that's all I gotta say. Blues, do you hate me now? Blues probably hates me now. How dare you? How dare you say there might be intelligence agents in our company? I think that was funny. I was at a startup company. I went to a startup company. I did an interview with the CEO years ago, and they paid me a lot of money. Back when I had sponsors, they were my best sponsor. They were a really good sponsor. Anyways, I got flown out to their headquarters, and I got to interview the CEO, and many other of their executives. And I still remember that when that conversation went sideways. And I was just sitting there. It was a 2-hour interview. So I was like, oh yeah, just out of curiosity, what are your counterintelligence capabilities? And then the guy just looked at me and was like, what do you mean? What are my counterintelligence capabilities? I'm like, well, you've got like 500 employees. You're installing your software into countless private enterprises. What are your counterintelligence capabilities? And that was a funny thing. Like, that's one of the weird things you get to is, again, when you've been dealing with people for a long time, right? There's times when people don't want to give you the answer. Like, they know the answer, but they're on a YouTube live show, so they don't want to tell the world. And then there are other times when people don't have an answer. And the funny thing was, like, when the CEO, the CEO talked about the business model, he talked about their architecture and infrastructure and coding base. He talked about, it was 2 hours, and he answered every question I gave him amazingly, up until I asked him what were his counterintelligence capabilities. At which point he got very, very, very quiet. And you're like, oh. And so when I talk about this, do be careful. Don't listen to me. Read the frickin' news. A lot of these vendors have intelligence agents embedded within the companies, and you need to be thinking about that when you're designing your systems. So anyways, that was a bit of a rant. But please do, because it's so weird. Again, if I rant a little bit more, it's so weird. Everybody's like, Eli, we're in the middle of our first cyber war. And it's like, one, no, we're not. But two, if we were, let's go with it. Why aren't you taking it more seriously? Again, there's more to being a technology professional than screaming, ah, right? Like if LLMs really are going to destroy the world, somebody has to build that infrastructure. And by God, you can hire me. Like, what? I mean, I'm just saying. Like, if LLMs are going to destroy the world, somebody needs to build the infrastructure to allow the LLMs to destroy the world. And, I'll come in at a nice rate in order to do that, right? That's what a lot of people don't think about. They're like, they want to scream. But they don't think about the work that's required. Like, it's easy to scream that we're in the middle of a cyber war. It's a lot harder to start designing or redesigning your architectures and infrastructure based off of a war footing. If you're watching this video and you honestly believe we're in the middle of a cyber war, and you're at a company that does not have counterintelligence capabilities, I'm not sure what to say. Literally not sure what to say. So anyways, I'm going to go before I get snarky. Because it's the new year. It's 2024. Eli's going to be a happy boy. Eli's done with that. Eli's done with the snark. Eli's done with being mean. Eli's done with being screaming at people. I'm just going to laugh. And have some fun. Anywho, so this was a bit of whatever. What is IoT? Some of the things that you need to think about with IoT. And with that, see you folks later.